Alright, this is a Yaz, Shmain, and Andrick with our poster on our home circuit. At my house, we have 20 amp breakers, as you can see here, and each outlet supports 120 volts. There's a 120 volt difference because there's 0 volts on this side and 120 here, as you can see. Now, we would give each of the devices, we were easily able to find the power in watts on the device. On the light bulbs, it's right on the top. It is in the back of the Xbox, back of the cable box, on a sticker on the fan, and on the back of the TV. And we were easily able to find the voltage, so these two were given to us. From there, we can find the current in amps and the resistance using Ohm's law and the power formula. To find current, we simply took the total power in watts and divided it by voltage. You can see an example of this for our first light bulb, which was a 100-watt light bulb with 120 volts running through it. Therefore, they're 0.83 amps. We repeated this process to find the values for this entire column, to find the amps of every device in this parallel circuit. After adding the current of each of the devices, we found the total current for this parallel circuit and found it to be 3.74 amps, which is well under the 20 amp point, at which point the circuit breaker would bust as a safety feature, which means it's a very safe circuit, mostly due to the fact that there is high resistance in a lot of the devices due to the sensitive components inside of them. To find resistance, we simply used a variation of Ohm's law, in which we found resistance by dividing voltage by current. The Xbox had 120 volts of voltage, and we divided that by the 0.29 amps, which we found from our last formula. That gave us 413.8 ohms of resistance, which is very high, but necessary in order to protect sensitive electronics like an Xbox or an iPod. We repeated the process down the column as we did before to find the rest of the values, and found that under a 20 amp breaker, this parallel circuit could be very well supported. That's all. Bye.